Our next talk is titled Unfinished Business, Installing a Hale-style Spectrohelioscope at Stellafane by Matt Considine. Just a little brief overview. In 1929, Russell Porter envisioned the installation of a Hale-style Spectrohelioscope on Breezy Hill. Efforts were begun to make this happen, but a variety of circumstances conspired to prevent it from coming to fruition. Decades later, an example owned by Gustavus Cook and coincidentally reviewed by Porter became available. In this talk, Matt Considine, a member of the Springfield Telescope makers, will give an overview of the instrument, the restoration needed, and its pending installation at Stellafane. So, ladies and gentlemen, please welcome Matt Considine.
I appreciate everybody taking the time to stop by this afternoon. This is entitled Unfinished Business, and you've kind of already gotten the Reader's Digest version, and I'm going to go into a little more detail as to why this is considered unfinished business here with the club. The picture you're looking at is an image of a prominence, solar prominence taken in H-alpha light, specific wavelength in the red area, if you want to think of it that way. And this was taken in 1936, I believe, with a Hale-style Spectrohelioscope. And specifically, it was taken with the Spectrohelioscope that we are planning on installing here at Stellafane. In the background, you can see an outline of a blueprint, and that is essentially the genesis of this project for me. But I'm going to start back in the early 1920s. In the early 1920s, George Ellery Hale developed a spectrohelioscope, or an instrument, to view the sun in virtually any wavelength for which one had a diffraction grating available, or rather, one would take a diffraction grating and could dial in various wavelengths from blue through to the red and observe the sun in that wavelength. Unlike modern telescopes like an H-alpha scope, for example, or a calcium K telescope, a spectrohelioscope can essentially look at the sun or image the sun in any wavelength rather than just one specific wavelength. Hale, when he was starting his project, or when he envisioned this instrument, he also envisioned a number of observatories set up around the world that would utilize this instrument and which would essentially form a network of solar observatories, allowing the sun to be researched and documented 24 hours a day, 365 days a year. He described this instrument in the Proceedings of the Astronomical Society of the Pacific in 1928, as well as in the amateur telescope making book that Porter and Ingalls co-authored, as well as in Astrophysics Journal. In Astrophysics Journal, in a series of 4 articles, Russell Porter provided the drawings for the instrument and for helping readers to envision how it would be laid out and used. Blueprints were also made up, and these were available from Mount Wilson. And one of the things that intrigued me when I first became acquainted with the amateur telescope making books was the fact that in the section that Hale contributed, he stated that these blueprints were available for $1. And I assumed that a number of people would have ordered these blueprints and that they were fairly easy to find. And at the time, I was working on building up a collection of amateur, essentially vintage amateur telescope making literature. And no matter what I did or where I looked, I could not find these blueprints or frankly any reference to these blueprints. This is an image from the amateur telescope making book, and it shows the layout of what's called a Hale-style Spectrohelioscope. And this is a drawing by Porter, and it was one that accompanied the blueprints. What you see here is, Okay. You can barely make out like a laser pointer here. So we have sunlight coming in, and it bounces off of this mirror, which is clock driven, up to a flat. Comes out to redirect through a singlet lens, which is a long focus, about 18 feet. It comes in into this building essentially, goes through a slit, bounces off a small mirror over here, concave mirror, comes back to a diffraction grating, which you can't see in this image, back out to another concave mirror, and then back to the observer through a slit where an eyepiece is being used. It's used to view the image. Apparently, though, a number of people did order the blueprints because 23 installations were eventually listed in 1931 as having been set up and in the midst of it having already installed spectrohelioscopes, or were in the midst of installing spectrohelioscopes. One of those installations belonged to a very wealthy amateur by the name of Gustavus Cook, who was located down outside of Philadelphia. He was an industrialist, as I mentioned, very wealthy, and somebody who had quite a passion for astronomy. It turns out he didn't actually build an instrument, but he had it made. And frankly, very few people ended up having them made. Certainly, very few amateurs have them made. One of the only ones that was completed in the United States was by a gentleman named Henry Prescott in Wells River, Vermont, just a bit north of here. Porter envisioned a spectrohelioscope from early days to be installed at Stellafane. In an article that he wrote to the club, or a letter he wrote to the club, and which was printed in the Springfield Reporter in 1929, he says he's out in California by this time. He has gone out to help Hale with his Palomar project. And he writes back, quite a little of my time is taken up with Dr. Hill's spectrohelioscope, which, as most of you know, is only a contrivance to watch the changing spots and prominences on the sun. While it is a remarkable little instrument, all the awe and mystery it had for me is gone now that I have become familiar with it. We shall surely have one in Springfield, where you can see those enormous plumes around the spots changing their shapes from hour to hour. We can use either form, vertical with the windmill tower at Stellafane, or down the ground horizontally. So clearly he's expecting that one of these instruments is going to get installed here on Greasy Hill. One set of blueprints did end up back here at Stellafane, and a gentleman by the name of Robert Penn, who was an early Springfield telescope maker and who worked at Jones and Lamson downtown. He built a ruling engine and had fraction gratings that he exhibited at a 1931, I believe, 1931 or 1930 Stellafane convention. Nevertheless, a speculum grating was provided by Porter himself, who was still out in California, and that was sent back to the club. In the meantime, in anticipation of an eclipse in 1932, construction was begun on the spectrohelioscope, and the blueprints that they had ordered were essentially heavily amended or doctored to try to simplify the instrument. A variety of events conspired in those early days to prevent the completion of the hardware associated with the spectrohelioscope. What was completed, you can see today in the Springfield Telescope Makers Museum down at the Hartness House. And if you actually look closely, if you know what to look for, you'll see a lot of machining that was left unfinished or partially done. So basically the way things stood in the 1930s was a grating had been provided by Russell Porter. A lot of the hardware had been machined by the folks here at the club, but the machining was never completed. And most importantly, the grating for a while had been loaned to Henry Prescott so that he could fully use his instrument, which he did. Unfortunately for Mr. Prescott, he was having some marital difficulties, and he was in the midst of a divorce when his house mysteriously burned down. And nobody was injured, but all his astronomical equipment was completely destroyed. And that included the diffraction grating that had been loaned by Russell Porter, or given by Russell Porter to the club and loaned by the club to Mr. Prescott. That pretty much put an end to the project. Mr. Cook, in the meantime, had contracted with essentially Fecker, who was an instrument maker down in Pennsylvania, as well as with Howell and Sherburne, which was a firm in Los Angeles, out in Pasadena actually, who was also making parts to these spectrohelioscopes. And Gustavus Cook, frankly, had a lot of money to throw around, and so he bought his instrument. He didn't actually make it. And he ordered from Fecker higher-end flats, as well as some other equipment to fill out his observatory. When Cook died in 1940, his observatory and his instruments were left to the University of Pennsylvania, which had their own observatory nearby. And eventually, these two observatories were consolidated. If you recall from the earlier schematic shown, a spectrohelioscope has a fairly large footprint. You've got roughly 18, 19 feet from the mirrors and the singlet lens to where the observer sits, and then you get another 13 or 14 feet in the light path to where the light is reflected back from a couple of concave mirrors. And then that also has some elbow room around it. Eventually, thin film technology supplanted this instrument. Obviously, filters and other technology was much more convenient to use than this rather unwieldy instrument. Spectrohelioscope wasn't used much. It was loaned at one point to the Navy in World War II for a use that I still haven't quite figured out yet. It came back to the University of Pennsylvania. It was kind of boxed up. It was then in the 1970s loaned out to LaSalle University, which at that point it was converted into essentially a very large spectroscope. And in that process, a couple of parts went missing. It was returned a few years later and set up at the Students' Observatory in West Philadelphia at UPenn's main campus. And that's an important thing for it to have happened for this instrument, because what happened, well, we'll get to that. This is a photograph from Scientific American showing Russell Porter here on the left and Gustavus Cook on the right. They are standing over Gustavus Cook's installation of the spectrohelioscope. I guess talking it over, as they say. Around 1937, this is what Cook's installation looked like. As I mentioned, keep in mind he had a lot of money. So he had a very nice, pier set up over here with a little case over here that went over the mirrors and the singlet lens. And he built this nice little shed, if you want to call it that, for the observer to sit in. Inside, this is a view of the rotating prisms and the eyepiece that the observer would use to observe the image of the sun. So what would happen is the light would come through the top here from the outside. It would bounce way over there off of a couple of mirrors, come back to a grating here, and make its way back to the observer. And these right here are what's called Anderson's prisms, which are essentially glass blocks. And in order to form the mirror, the image of the sun, they need to spin. And that at the time was driven, or that motion was provided by an old GE fan motor, which you can see here off on the left. Another view, this shows the diffraction grating, labeled A. The diffraction grating was a large piece of, well, maybe 4x4 piece of speculum metal. which was polished flat and then ruled on a grating engine that was installed out at Mount Wilson in 1930. So another view of Cook's installation where you can barely make out the two mirrors that are used to provide the return beam to the grating and then to the eyepiece. And then these are photographs that were taken through the instrument and which you can actually see located up in the clubhouse, the big clubhouse today. They're on the right wall as you walk in, along the shelf. And these are photographs of prominences that were taken with Cook's instrument. And Cook autographed the photographs and sent them back to the clubhouse to Russell Ford, on behalf of Russell Ford. Okay, so back at the start, I mentioned that I had been interested in tracking down these blueprints. I eventually ended up out at Mount Wilson going through stacks of blueprints and found a set, and they were willing to let me have, found a duplicate set, which they were willing to let me have. And I thought that that sort of ended the project. However, in the meantime, I had come across this installation at Penn, and I was living down near Penn at the time. And I had come across the installation because I had seen them listed, and I had inquired with them. I see that you've got one of these instruments, do you happen to have the blueprints? No, we don't have the blueprints, but we still have this thing. And I was kind of surprised. I asked if I could see it, and they led me to the top of the physics building in downtown Philadelphia for all intents and purposes. And sure enough, jury-rigged installation was this Hale-style Spectrohelioscope, still set up as a spectroscope, essentially not functioning in the way it was intended. It was really only set up to provide a spectrum of the sun, something you could do with much less elaborate equipment. But again, because it takes up such a large footprint, and this was a relatively small rooftop observatory, it was starting to get in the way of it. And they called me up one day, sent an email actually, and said, you know, if you're interested in this, if you're still interested in it, we're thinking of getting rid of it, you can have it if you can move it. So that's 2006. I was working, like I said, outside of Philadelphia, down near Delaware. I was working for DuPont, and a colleague of mine, Dave Grosky, also a club member, he and I have been in constant touch over the years, not only about regular telescope making techniques, and he was helping me out quite a bit on my own efforts, but he was keenly interested in spectrohelioscopes, and in particular an old spectrohelioscope. I had kept him kind of apprised of my interest in finding the blueprints, and so when I got this email, I called him up and I said, Dave, here's the deal. I need some help. It's the middle of June, it's hotter than all get out. Will you help me get this thing out of Penn? He said, sure. So we hightailed it up the highway. They opened up the building for us. We thought we'd be able to roll back the roof, but we couldn't. If any of you have ever been in the middle of Philadelphia in the middle of summer, you can imagine what it's like under a steel or metal roof. But they were good sports about it and gave us what equipment they had, and we assembled the spectrohelioscope and piled it into my car. With the exception of the rotating prisms, one slit, and a couple of odds and ends, the instrument was complete, which really surprised me. What had happened in 2007 is that UPenn had taken the installation that they had inherited, and by 2007 it had been sold to a private developer. And the building was falling into disrepair, the equipment was falling into disrepair, it was being vandalized, and frankly the new owner had absolutely no interest in either restoring or running an observatory. And it got to the point where the observatory got demolished. Bart Freed, hanging out somewhere in the back over there, was instrumental in salvaging and saving and preserving what instruments were left just before the wrecking ball came in. But because the spectrohelioscope, when it had been returned to Penn, had never been put back in the observatory, it essentially had been, preserved by neglect, if you want to call it that. And again, with the exception of a few missing parts, was complete. And in my search to find all the other blueprints, I contacted a lot of organizations, and there weren't any other installations that I could find, complete installations that I could find. So this was really very fortuitous. Here's an idea of what it looked like while I was installed at Penn. This is one of the reflecting, one of the flats. This has been installed about 8-9 feet up on a wall. There's a singlet over here. There were some other odds and ends that were used to redirect the beam down the wall. They mounted the reflecting concave mirrors at a 90-degree angle on a wall. The diffraction grating was also mounted at a 90-degree angle, but because it was a roll-off roof and not well protected, there was a little bit of water damage, but still relatively well preserved. And then this is a view of what the eyepiece and the observer's side of things look like. This is what Porter's drawing looked like, or shows what it looks like when it's properly configured. So, where we stand now, as of, say, a couple of years ago, is I'm sitting with Dave's help with Spectrohelioscope. Springfield telescope makers have some unfinished business that had sort of gone off the radar screen a little bit. Penn has gotten rid of an instrument that was in their way. And frankly, I felt that I didn't really own this. I was just being a steward of the instrument. And what I felt the most appropriate use of the instrument was, or the most appropriate place to put the instrument, or to erect the instrument, was here at Grizzly Hill. I offered to donate the instrument at no cost if the club was willing to essentially have it reinstalled and used in the way it was originally intended, which was not to be used as a spectroscope, but to allow people to see the sun's activity in a variety of wavelengths, to use it as an educational instrument. And given that this organization has education and outreach as a mandate, it just made a ton of sense. The club had generously accepted the offer, and we have begun that process. Let's see. So, where we stand today is there are some parts that need to be recreated. However, we have all the blueprints. And we confirmed that we have a complete set of blueprints from an index listed at Mount Wilson. Since most of the parts that need to be recreated are of a mechanical nature, not an optical nature, they shouldn't provide an unusual hurdle. We have all the optics, we have all the lenses, we have the diffraction grating, we have the reflecting mirrors, and courtesy Bart Freed, we have Anderson prisms as well. We do need to build a structure and identify a location to install, to put this building up. Here's an example of what some of the missing parts are. We have a bracket here, shouldn't be too hard to replace. We have a mounting mechanism for the singlet lens, that won't be too hard, as well as some control rods over here controlling one of the flats. We even have this old clock drive, which I'd be shocked if it still worked, but conceivably we could even get that going. On the eyepiece end, we need to reconstruct the armature for the rotating prisms, as well as reproduce one of the slits. And then over here, we need to have a line shifter installed, and that's just really a little piece of plate glass, nothing fancy about that. For those of you who have not been put asleep yet, you'll wonder, yeah, but you don't have the GE motor that drove the rotating prisms. Not quite right. I actually found one on Craigslist. So I've got a vintage 1935 GE fan that looks exactly like that. You take the fan blades off. That probably won't really get used, but we could go there if we needed to. The proposed location for the spectrohelioscope, well, there have been a couple of locations that have been proposed. What we are considering most seriously now is this site over here on the right, the lower right-hand corner. This is an aerial view courtesy of Al Rifkin from a couple of years ago, I believe. This is the Penn Clubhouse. This is the Porter Telescope. And over here, where some kids might have been picking blueberries, is the property line for the original location of Greasy Hill. And for a variety of reasons, we need to have an offset to that property line. So we need to move it over a little bit. And that's going to essentially put us in the location of what is now not too large, but not too pretty pine tree or fir tree. I'm not exactly sure of those species. And on a somewhat sloped area. So what we are considering doing is leveling off this area by adding some fill and getting a structure built there. It would be a new building, roughly 10 by 20, in what we're calling the gully area. It would be custom built, so the instrument's going to fit in it quite well. The eastern horizon is very good relative to a spot that had been considered earlier that was a little too close to the tree line. The western horizon, where you folks look out and see the mountains and the landscape, is obviously quite nice. The cost is going to be relatively minimal. The lumber is going to be provided by a sawmill that we have on site. And so we're going to do this all ourselves. Obviously, the instrument's not going to cost anything. We do have to get some permitting done, and that's Ken Slater has been doing great work spearheading that effort. There's going to be some ventilation and some power required, but again, nothing extraordinary, certainly nothing that the club and the resources that we already have and the people that we've got can't pull off. An overview location, an overview plan view is something like this. There's a couple of alternatives as to where the seal stack could be placed. But you can see it's a fairly basic building layout, about total footprint maybe 15 by 20 or so, something like that. 10 by 35. And it'll fit very nicely in that spot that I mentioned earlier. I don't know if it'll end up looking exactly like that, but the idea is to try to make it fit in. I mean, we're not looking to have something that would stick out like a sore thumb, but the idea is to try to hew to as much as we can, I think, Porter's goal, which is to have an instrument that serves an educational purpose, and obviously aesthetically, we'd like to have it blend in as much as we can with the existing structures while making all the necessary concessions to modern technology that makes sense. There are a couple of people that really deserve credit here, and I wanted to call them out. The gentleman who helped me at Penn was a guy by the name of Simon Dicker, and he was incredibly generous in returning voicemails, returning emails, and allowing access to this site, as well as, most importantly, remembering when it became an obstacle for them, rather than just tossing it into the dumpster, like, frankly, Penn had done with some other things, to call me and say, this is we're going to be getting rid of this thing, but it's yours if you want it. And without that connection on his part, without him actually caring, I would never have known that this thing was coming available. I couldn't have gotten it out of the building without Dave Grosky's help, but he also had provided in the time up to that quite a bit of orientation help, if you will, with respect to spectrohelioscopes and the theory behind it, and sort of the importance of this particular type of instrument. And subsequent to that, he's been very helpful in offering to get this instrument set up in a sort of test pattern or on a test bed to make sure that we know what we're working with. Larry Webster out at Mount Wilson was incredibly generous with letting me come out there and go through a rather unorganized archive of blueprints. He spent a great deal of time with me. And when we determined that we had a completely duplicate set, he was generous enough to let me have that. And again, if it weren't for him providing a full set of blueprints, we couldn't be putting this thing back together in all likelihood. And finally, Ken, with the work that he's done, certainly this year, in trying to spearhead the effort to get the permitting needed, to get the club moving in the right direction, getting the site walked, figuring out the location, and frankly, all the other Springfield telescope makers who have very generously agreed to accept the donation and to help make this a reality. If it weren't for this club, the folks in it, this certainly wasn't going to happen, at least not in a way that I think justifies the instrument and the original intent would have. A little bit of a rambling presentation, I guess, but I'm happy to take any questions.
Plenty of time for questions, I'm sure.
You first.
Your intent on making it the way Russ Porter envisioned it in the 1930s, you have to substitute minor improvements.
So the question was, given that I said that we were going to try to set it up as Porter envisioned, are we not going to use any modern equipment? And I can't say that that's not going to happen. I think it would be, personally, I think it would be interesting to set it up with as much of the original equipment as we possibly could, just to understand what the experience was. I'm a member of the Antique Telescope Society, a number of folks in the audience are, and I think we all appreciate looking through an old instrument and trying to put ourselves in the place of somebody who was 50 or 100 or 200 years ago, imagining what they were seeing. And so for at least a little short window, I'd like to once look through it with the diffraction grating clean. But in all honesty, what makes sense is to substitute the modern equipment where it makes sense. So Dave, for example, has got modern diffraction gratings, which are just much better. There's no two ways around it. And I think where it makes sense with, say, a driving clock, that be substituted, we would make the necessary substitutions, with the idea being that at the end of the day, it's for people to look through. It's for people when they come to convention to get an added educational experience. It's great to look through the Porter telescope and you can see the sunspots. If anybody's seen the sun today, you can kind of use a little bit of a wow factor. It would be neat to sort of walk across the gully and then look at the sun in H alpha light or calcium K, and to, I think, really make that educational experience as deep and as genuine as possible. I would be on board with using modern equipment. Question here.
How many lines grade to the grade the outcome?
Okay. The question was, what should the resolution of the grading be, the lines per inch, for it to be optimum? The configuration that we have here, the diffraction grading, the original diffraction grading is, I think, 14,000 lines per inch. Say again, Dave?
600 lines per millimeter. The original one was 600 lines.
The original one was 600 lines per millimeter. I think that we would be able to have, sorry? We could double that with modern diffraction grading. So the resolution would be a lot higher, and it would be improved from that perspective. sorry?
Probably, no, the length of the system is really driven by the focal length of the concave mirrors on the far right, and those are 13 feet. We have those mirrors, and I'm going to have to plead ignorance to not knowing the math in my head for the spectrohelioscope. Dave might have some help. The objective gives you the resolution of the sun, angle resolution of the sun. Okay? The length of the mirrors and the number of lines on the grating gives you the spectrum. What you want to do is, when they made this instrument, they had fairly low resolution rate, 600 lines of focal. They had to make the focal length very long to make the lines wide enough so that you could put a slit to isolate and make monochromatic color. So when you go to a higher resolution grating, well, it's the next big thing shorter than these. So we won't do that because it does keep a pad on it. It makes the slit mechanism. You don't have to use the size. We actually get a narrow band. Now the line is wider. So we talk about more of that narrow band.
Yes, sir. How faithful was the cooking instrument to the blueprints? Were they identical?
The question is, how faithful was the Cook instrument to the blueprints? And the answer is they're dead on. The singlets focal length is exactly what's in the blueprints. It is a variant of, in the blueprints there are a couple of variations that were laid out, the vertical spectrohelioscope, this is a horizontal. Some had rotating prisms like this one. Others had oscillating slits which bounce back and forth. So this is faithful to one of the original layouts and vision. Question? Sure. The question was in reference to the Anderson prisms, what glass is used in what we
Say again?
PK7.
John?
They're surviving at Pomona College in California is an example of one of these Sherburne and Powell instruments. And I saw the thing, and my impression of it was that mechanically it was a fair bit bigger and heavier than the one in the museum here now. And so, and I've seen, I've heard about some of those drawings about Wilson, and I speculated to myself that maybe the one here in the museum was like these drawings, but when this company out in California to build some of the big gears, for example, for the 100-inch and 200-inch, they might have changed the mechanical design a little bit. But in it, whatever those details, that's at least one other example of one that is reasonably complete, but I'm not that sure many people know about this one at Pomona College. It might be worth visiting sometime.
Yeah, that's a good point. I did actually find White Observatory at Wellesley had an instrument, had an installation of this instrument, and they have some of the components still installed. I don't believe they use it though. And Haverford College allegedly had some parts still extant from their installation, but nobody could ever verify that. And I think you might have mentioned in Michigan, there might be an example out of Michigan.
One I remember, there's supposed to be one in Vassar, but I tried to track that one down, they said it was gone.
Yeah, I went through every installation that was listed by Hale in the U.S. I contacted to try to determine what was left. And the Penn one, I mean, some I obviously didn't get replies from, or didn't get in touch with the right person, but the Penn one was the only one that came up as still extended. Rick?
How big is the singlet lamp?
The singlet's, I think, 4¼ inches in diameter, and it's long focus, it's a cross lens, and so minimum spherical aberration. It's maybe less than half an inch thick. Ideally, to the earlier question about would you use some better technology, one could make a singlet, I think, that would have would be corrected for H alpha and calcium K, and then you would have relatively short distance to travel in focus adjustment when you went from one end of the spectrum to the other. The singlet, as it's designed, is optimized for only H alpha, the original implementation.
Ford mentioned in his letter the possibility of using the tower next to the clubhouse. What was he considering? What were the downsides?
The question is, what was it considered to use the tower next to the clubhouse, and what are the downsides? I don't know if we considered at the time or considered now to use it. The tower that's there is not set up, would not be stable enough for housing the instrumentation. Although I think that from a thermal perspective, Jim Daly would be able to correct me if I mess this up, but it would be easier to have a stable column of air in that kind of a setup rather than having a horizontal setup from an image quality perspective. But I never found any reference to there actually even really being considered in the 1920s or 1930 a vertical installation here at Stellafane. They seem to, as best I can tell, the planes they were working from were the horizontal, was the horizontal implementation, and haven't found any information as to where they were envisioning it located though. Justin?
Is there any timeline that you hope to have this set up?
So the question is, what timeline, is there a timeline by which we hope to have this set up? Having established that there's a likely site, assuming we went with this, and the permitting all takes place at whatever pace the state of Vermont allows it to take place, I guess we were thinking that construction might start next spring with maybe an aggressive goal of having it available for the next year's convention. But that might be aggressive. We'll find out. Hi. I'm sure we'd be happy to take donation for it. But I don't think that's not the I don't think that's the idea is not to collect for it. I mean, I think that was just frankly that slide came from an internal. We did a comparison of two sites, and we were trying to guesstimate how much would it cost likely to do one version versus another. So that's where that comes from. Any other questions? Thank you very much.